Good day, viewers at home. This is Helizchem channel. Today we want to look at balancing of redox reactions. Balancing of redox reactions. On this topic, we shall be discussing steps involved in balancing simple ionic redox equation. But before then, I want to quickly chip in something that if you want to balance redox reaction, the procedures or steps to use or the steps to follow depend on whether the equation given is simple or complex. Aside that, you must check if the equation or the reaction is taking place in acidic, basic, or neutral medium. So all these things are very essential if you want to balance redox reactions. A redox reaction is termed to be a simple ionic if all the ions in the equation contain atoms from single elements. But if it is a complex redox equation, then it means that the equation contains two or more atoms from different elements. That is what we call radicals. But today, we want to look at the steps involved in balancing simple ionic redox equation. Simple ionic redox equation. What are the steps? And the method you want to use is half reaction method. If you go to my channel, I have discussed extensively on how to write half reaction equations. So today we want to use half reaction method to balance simple ionic redox equation. Step number 1. Assign oxidation number per atom. So you have to assign the oxidation number to each atom that is involved in the reaction. Number 2, separate this reaction into half reactions. Like I said, we have two half reactions. We have oxidation half and we have reduction half. So you have to separate the redox equation into two half reactions. Having done that, you balance each half reactions. How do you go about the balancing? To balance each half reaction, you must add appropriate coefficients so that you balance the atom. After balancing the atom, you add appropriate number of electrons to the side with more positive or less negative charges. Then number 4, multiply each half reaction by appropriate coefficient to balance electron gain or electron loss. Then the final step is to add the two half reactions together so as to obtain what we call net equation. So today, I want to consider a typical example here to explain all the steps listed above. And what is the example? The example says, balance this reaction by half reaction method. You have Fe plus Ag plus aqueous to give Fe2 plus aqueous plus Ag solid. Solution now. The first thing is to rewrite the equation. Fe solid plus Ag plus aqueous to give Fe2 plus Aq plus Ag solid. Then our step number 1 says assign what? Oxidation number. So this will be 0 plus 1 plus 2, 0. So we have assigned oxidation number. This is step 1 now. Step 2 says separate into 2 half reaction. So we want to separate into 2 half reactions, which is oxidation half and reduction half. So this is oxidation half, this is reduction half. We are separating. Our oxidation half, if you look at it, oxidation means increase in oxidation number. So, and if you look at this reaction now, the ion with oxidation number of 0 is going to +2. That is oxidation. So you will write that. Then for reduction, there will be decrease. So our silver aqueous is going to what? Silver solid. So we have completed step 2, which says separate into 2 half. Then step 3, balance each half reactions. We have to balance atom wise and electron wise. Let's look at the atom. Here, this is 1 atom of iron, this is 1 atom of iron. So we can see that is balanced. If you go to this side too, 1 atom of silver, 1 atom of silver. So we have done that. They are balanced. Then if you look at the electron, this is +2. There's no electron here, so we have to balance it. If you look at this now, this is 2 electrons. Like oxidation is loss of electrons, so this one will lose 2 electrons to become Fe2 plus aqueous, and this one will gain 1 electron to become Ag solid. Said you have to interchange this because we don't write negative equation in chemistry. So we have this now, then we have this here. Step number 4, multiply each half reaction by appropriate coefficient to balance electron gain or loss. If you look at this oxidation half, we have 2 electrons here, but if you look at the reduction half here, we have 1. So the two reactions must complement each other. So the same number of electrons that are lost here must be gained in reduction. So you have to multiply by 2. So when you multiply by 2 here, we have 2Ag plus aqueous plus 2E to give 2Ag solid. So this one still remain like this. Then the last step now say add the 2 half equation together to obtain our net reaction. So let us add it together. This is oxidation half, reduction half. We want to add them together now. This is Fe solid going into Fe2 plus aqueous plus 2E minus, and this is 2Ag plus aqueous plus 2E minus to give 2Ag solid. So we want to add the 2 together now. we have Fe solid plus 2Ag plus aqueous plus 2E to give Fe2 plus aqueous plus 2E minus plus 2Ag solid. So this one electron will cancel each other and we are left with Fe solid plus 2Ag plus aqueous to give Fe2 plus aqueous plus 2Ag. If you look at this equation now, we have successfully balanced the simple ionic redox equation. I hope you got value from this video. Please put your comments on the channel for me, and if there's anything, any topic of your interest in chemistry that you want me to treat, get in touch with me. Don't forget to share, follow and like. Helizchem got you covered.